Good afternoon, everyone. I suspect that our next guest this afternoon requires very little in the way of an introduction, but for those of you who have been on a silent meditation retreat for the last 16 years, he was CEO of Google for a decade, and since 2011 has been executive chairman, now executive chairman of Alphabet. So I'd like to welcome Mr. Eric Schmidt.
Hi, Gideon. Thank you, guys. Hi, Gideon. Nice to see you.
So I think the expectation here this afternoon is that we're going to be talking about the future of AI and machine learning. But I thought that maybe we would, given your institutional history, to start with the past. Because so often these days, we read about AI and ML in the paper every day, but there's this sense that it's just taken, that the definition of artificial intelligence is something self-evidently taken for granted, that we all know, it's Scarlett Johansson in the Spike Jonze movie or whatever it is. But AI has actually meant a lot of different things over time, and it has a history of overpromising and under-delivering and a complicated relationship to the business cycle. So I wonder, given your experiences, at a number of places that have been involved with AI research, Princeton and Berkeley, and then Bell Labs and Xerox PARC and Sun, Novell, and now obviously Google, although we'll maybe wait and talk about Google in a minute. I just wonder if you could give us a kind of historical tour through how you've seen the concept and the aspirations for AI change over time at these various institutions.
Well, thank you very much. And it's really great to be back here. This is the site of many, many Google events and many, many Apple events, including the iPhone launch. So it's wonderful to think now what's new and what's different. And I would say that what's really new is the emergence of security, not just in the kind that we're talking about today, but also nation-state security issues, as well as machine learning and the things that are going to happen in the future. So it's wonderful to be here. So when I was a PhD student, AI was the rage, and this was 40 years ago. And the whole idea was that AI would progress very, very quickly using language models that people were proving correct. And there was a small little component of it around neural networks that sort of didn't really go anywhere. And somewhere around the 1980s, there was the beginning of what is known as the AI winter, roughly 20 years where the smart AI people tended to be few, and most people had gone into other areas, right, which were doing really well. And somewhere around, 2000, a set of scientists and mathematicians, notably led by a guy named Jeff Hinton, who recruited a number of other people, and he's a Canadian, came up with essentially deep neural networks, that is the layered math around neural networks, which is the beginning of the current explosion. And I, being prejudiced from my sort of years of winter, when I first saw the results involving vision and speech, and we used it in our ad systems a little bit, I said, it won't scale, it won't really generalize. These are mathematical techniques that are simple improvements in good engineering. And I've been proven completely wrong.
Well, so to speak specifically about Google then, so even before you would come to Google, in the earliest interviews with Larry and Sergey, they talk about Google as an artificial intelligence company. And then very early, you guys hired Peter Norvig, who, of course, literally wrote the textbook on artificial intelligence as the director of research. And he had said at the time in an interview that he hadn't actually wanted to set up a specific part of the organization that was going to do AI research because he thought it should be part of everything.
What was interesting was when we hired Peter, it didn't occur to me that he was an AI researcher. He was just a brilliant researcher. That's how little we understood of the consequences of hiring the foremost researcher. We just didn't think it would scale that way. And most of Peter's early work as our research lead was not, in fact, in AI.
Right. So, it took until 2011 for you guys to ultimately decide that you wanted to set up a division of the company headed by, at first, Andrew Ng and later Jeff Dean, called Google Brain to do...
No, but the other thing that happened was the cat videos.
Well, the cat, right, but that's a year
I mean,
after.
no, but I mean, come on. I mean, the rest of us are going like, okay, whatever. And then they did this discovery where they discovered the concept of cats by watching YouTube videos. Now, I would have liked them to have discovered something more profound. I was very upset. I mean, it seems to me that if you're index discovery in computer science and in AI, the event that launched, the quest for general AI, you'd think you would have discovered like, basic set theory or something like that. But instead, they discovered cats in YouTube.
Well, but of course, this is part of the change that happened in AI, over the past 60 years, right? Which is that for a very long time, the expectation was that this was going to work on what we imagine to be very higher order cognitive registers of things like set theory or the rules of chess, but that more recently the turn has been toward how do you actually get computers to do very basic things that you would associate with a 1 or 2-year-old.
I think it's clear that the change was easy to see in hindsight and impossible to see at the time. We knew that the computational power of these systems was exploding in Moore's law ways, which means exponentially doubling every couple of years. And certainly Google was pouring an enormous amount into these data centers. What we did not understand was that simple algorithms, or what appear to be simple algorithms, could replicate what were incredibly complicated taxonomies that had been designed by humans earlier. So the key thing is that large-scale simple analysis can appear to emulate very complex things.
Right, but it did require a big leap of faith to decide to make this, to allocate these resources to a special department to do this. I mean, basically they'd had no real significant results in 40 years, and then Google was basically the first major commercial institution after really the Canadian, non-commercial, the Canadian government invested a lot in this.
Yeah, and thank goodness for the Canadians. Let's say some nice things about Canadians.
So I wonder, I don't know if this is a decision that you were a part of, but I wonder about that original decision in 2011, which really can be credited with setting off the machine learning boom we have here.
So I give that credit to Alan Eustace, who was running it at the time, Larry Page. And Larry's PhD work was, by the way, in AI, and he'd always believed in it. And we used to bait him, and we'd say, what, you're running an AI company? Look, right? We'd have fun with Larry because he so deeply believed in the principles that he'd studied as a graduate student at Stanford, and he's been proven right. And so as Andrew...
But what do you think those principles are? Like, what do you think AI as a concept meant to Larry?
A belief that at scale, these algorithms can reproduce things which look like human ability. Right, that's the way. I was always skeptical, and as I said, I was always wrong about this, as many other people were. But I think the cat video showed that the concept of unplanned learning, which is what the cat video represents, was the beginning of something much more powerful. We had for some time neural networks that were used in our advertising system. And we had a system which was unfortunately named SmartAss at the time. And we saw algorithmic improvements in ads, right? But again, we didn't make the leap from there to this more generalized artificial intelligence capability. So I remember, again, around that time, hauling the various scientists in and saying, look, what's really going on here, right? What is the real breakthrough? And that's when I became aware of the possibility of deep learning. Today, when you use Google Speech, Google Photos, in many cases, you're using neural nets that are 10, 11, or 12 layers deep. And if you're not familiar with what this means, think of it as you have a photograph. The first layer says, hey, this is a box with some bits in it. The second layer says, here are the outlines of the things. The third thing, these are the colors. The fourth says, oh, here's a shape. The fifth one says, that's a human shape, and so forth. So think of it as a cascading level of, shall we say, resolution at each layer.
So then the most recent public step, at least for Google in the last year, was that Sundar Pichai started going around talking about Google as an AI-first company. So I wonder, he's talked a lot about that in terms of a platform for a mobile assistant, but I wonder what do you think that means in particular? It sounds great marketing-wise, but... Well,
we're not really a marketing company. We're really a does the product work company. And so what happened was we had adopted a mobile-first strategy, which I had used starting around 2009, roughly speaking, around when iPhone and Android came out, trying to get our employee base and our apps and so forth to mobile computing. So one way to understand this is we've gone from mobile first to AI first. That doesn't mean you don't do mobile. It just means it's the newest thing that we have to adopt. So the canonical computer architecture today is mobile devices, Android or iPhone, by the way, in that order, so we're clear. Very fast networks that are secure, and then cloud computing, powerful servers, Amazon, Google Cloud, Azure, so forth and so on. And then the layers on top of that. So when we say AI first, what we mean is take these algorithms and apply them to all of the business problems, search problems, and so forth. The easiest way to think about why is where does AI of the kind we're talking about work the best? It's when you have a large amount of training data. So do we have a lot of training data? Yes. Right? So in Google Photos, for example, we have millions of people who said, here's a picture of a gazelle, and here's a picture of a lion, and the two are different. And we can train, that is, do classical learning against those pictures. And so when a new photograph comes up, we can say, hey, this is a picture of a lion next to a gazelle and busy eating it, or whatever. And so we've been trained to that. Well, that mechanism that I'm describing applies to many, many different things. One of the more interesting and more recent results, which we announced, was our improvements in our data centers. So here we have data centers, which I will argue immodestly have the best engineers in the world designing them to be by far the most efficient. I mean in terms of power and usage and fans and things like this. So building using reinforcement learning, different technology, we're able to get a power use improvement of 15%. This is against the best humans design could ever be done. So that gives you a sense of how good these algorithms have become. Again, large amounts of data.
So I wonder what that means in general, given that for this stuff to work, you need tremendous amounts of data, which of course, Google has peerless reserves of data, and then you need huge amount of computational power. What that does for the landscape here in the Valley of the dynamics between startups and incumbents. I mean, because it seems like a lot of this machine learning stuff is almost impossible for like the tinkerer in the garage to do because it requires such tremendous institutional investment.
Well, the first thing is that there are plenty of reservoirs of public data that are available to that garage researcher, and it's important that we encourage all of that. You need the training data. The other thing is that there are researchers now.
Well, but for example, in Google Translate, the biggest public data set for English French, for example, is like a 1,000th the size of Google's private data set. So there are some.
That's a good example where our product should be better just based on the quality of the data, but perhaps this garage can produce an even better algorithm than our best scientists, in which case we're going to sort of be upset. But that's good. That's called competition. And but the simplest example is you want as much public data as possible. There are people who are working on these algorithms to make them more data efficient. That is, to need less data to be accurate, using various very complicated mathematical techniques, and that's a solution. I should also mention, and you and I did not chat about this, that this morning we announced a new library called TensorFlow 1.0. And this, if you're not familiar with TensorFlow, it's an open source library that we Google use internally, that we have launched, which all of our competitors and hopefully all of you will be using. The first version, which was released last year, a beta version, included, for example, a photo classifier, a vision classifier, just for free. So you could use that. Again, you have to have your own data. And it runs, as I said, open source, and people have been modifying and extending this. This new version includes many traditional AI libraries, even traditional AI libraries that are not learning derived, as well as huge improvements and so forth, again, free. We're doing this because we're trying to stimulate the industry. We want you to build these solutions and identify these new opportunities.
So to turn then to issues of security. So you, over the course of your career, have watched computing move from mainframes to time sharing to PC to mobile and now to AI first. And in each one of these shifts, there's had to be a corresponding shift in the security view. And you've been working on networking technology since your days at BerkNet in the 70s, and then, of course, through Novell. So I wonder,
I should admit that when I got my master's degree, because I built a network at Berkeley, and I also built a mail system as part of that, which had the -R flag, which would allow you to impersonate anyone you want. So to say that the difference in mind view or worldview today versus then, right, it didn't even occur to us as researchers that there would be evil people among our university. And one of the academic questions is, imagine if the internet had been designed knowing what you know today about the need for security at the packet level, deep packet inspection, encryption, and so forth. Would it have ever happened? In other words, if you start putting all that loading on these relatively simple end-to-end concepts that the internet is, would it have been able to get as much steam as it did? We now find ourselves back fixing it over and over again. And you keep saying, well, why didn't they think about this? Well, the answer is, I can tell you I was there. It didn't occur to us that there were criminals, right? It didn't occur to us that these kinds of behaviors would occur.
Well, at what point did it start occurring to people?
Well, it turns out that there was a hacker when I was at Sun who actually attacked a number of internet things. And there was a particular reporter from the New York Times and a particular investigator engineer named Satomo. And they tracked this guy, and ultimately he was found and prosecuted for it. And that was, I think, the moment. It was heavily publicized. I think that was the moment where the internet community woke up and said, oh my God, right, we've got to actually secure this. Now, it's taken us 30 years, if you will, to get that. And the good news is we've not lost the openness and the end-to-end principles of the internet while doing it.
Well, so are there relevant examples that you can think of from platform shifts in the past in terms of how there have been corresponding shifts in security concerns that you think ought to be brought to bear on this shift from mobile first to AI first?
I'm not sure there's an obvious connection. I'm extremely worried about the likelihood that countries will begin to block the openness and interconnectedness of the internet. I wrote a book on this. I said I was worried about the balkanization of the internet, and the people from the Balkans complained. So let's just say that we benefit from the open interconnectivity of the internet. And we spend all day at Google dealing with the situation where this country is unhappy about this content which is coming from this other country. And there's huge issues about all of that. But at the end of the day, the globalization that we see, the economic growth that we see is heavily dependent on this. So I'm also worried that the fear of security, this fear over the internet and attacks over the internet will be used as a pretext to shut down some of this access. And so I'm worried about that. I'm worried furthermore that the machine learning capabilities that we're discussing today need to be done in the open and not by military research labs. And I want to make the point precisely. You can imagine a different scenario, that this stuff that I'm talking about now, which again is completely in the open and completely available to you, that somehow we had arrived at a different outcome and it was being done in military research labs between countries. So all of a sudden we'd spend all day worrying if they were in our networks, we wouldn't know what they were doing. The internet would begin to start getting shut down because of fear of the Russians or the Chinese or bilaterally. And so one of the questions that I think the industry should be asking is, can we come up with a way where the countries agree to not use the machine learning technologies in a way that militarizes the internet? In other words, a demilitarization plan, right? And maybe I'm an optimist, but I'd like to see some discussions about that.
I mean, presumably that would involve very strong regulatory pushes that it's hard to imagine.
Well, there was a meeting last year between President Xi of China and President Obama where they agreed to reduce the number of attacks from China to the United States. And for all I know, I've not been briefed on this. Perhaps there are US to China as well. And there's some evidence that that worked. So I think getting the governments to agree that we are better off collectively by having a more open internet with less attacking, especially at a nation-state level, would be a clear improvement for everybody.
I mean, it's interesting, there's sort of a flip side to this regulatory stuff, because one of the things that I've heard a lot from machine learning researchers is that China is poised to far outstrip the kind of research that we're doing, largely because they don't have anything close to the sorts of privacy laws and concerns that we do. And that if you don't have HIPAA laws, for example, you can do tremendously advanced work on healthcare applications of machine learning that can happen in China in ways that they can't happen here. Do you think that this is a cause for concern? Or?
So I think there's a number of things that you've referred to there. First place, on the HIPAA laws, for those of you who don't know, there is this very strong law about HIPAA, which means that use of the data for uses medical data that's other than ones that have been agreed to contractually are not appropriate. My own view is that many people use the HIPAA laws to avoid actually doing anything, right? And that there's enormous benefit to building, for example, research data sets so that research scientists can use the machine learning of the kind that I'm describing to actually solve disease problems. And some of these large databases should be done that. We're at the point now where if you have a numeric sequence, 1, 2, 3, 4, series of numbers, we're getting pretty good at predicting the following number. And you say, oh, okay, well, that's kind of interesting. By the way, that's healthcare, because healthcare is your medical record, all of your life experiences, one after the other. And the question is, you show up in the hospital, and your question is, what's going to happen to me? And with enough data and enough data analysis, I think it should be possible to get a pretty good predictor to assist the doctor in saving your life, and especially doing this quickly. We have a number of small experiments trying to do this. But again, the privacy laws need to be put in context. I'm not suggesting that they're wrong, but I'm suggesting, for example, that the research that's necessary to develop these algorithms is something that we should do, and it should be consistent with HIPAA. With respect to China, again, China is likely to do extremely well in artificial intelligence and machine learning because they are, as a country, developing very quickly math and science skills, and they're trying to move ahead. And they have a number of companies that are working in this area. And I think that competition is not so bad as long as it's done in the open, right? As long as they know what we're doing and we know what they're doing. A while ago, I talked about this, and I suggested that there are a number of principles that this should be operated under. One is that the research should be done in the open. The second is that the work that we're all doing should be done for the benefit of the many, not the few. In other words, when you apply these technologies, broadly speaking, they should apply to every human and every opportunity in every country. And the third is that you need to be doing research on things which do what you think they're doing. This is known as the do what I say model, as opposed to robots going out of control in the lab in whatever movie you've been watching recently.
We were about to get to robots getting out of control in the lab, so that's a great segue. It seems like one can break down the conversation about machine learning and protection into two pretty broad categories. There's what tends to come under the heading of safety, AI safety, which usually means, as an example, you have your Roomba, and the Roomba has the objective function to get rid of messes, and the
Roomba killed the dog.
Well, the Roomba realizes that the best way to get rid of messes is to get rid of the wetware that causes messes.
That's right.
And then,
I'm sure Roomba denies it's ever possible to defend Roomba here.
But then on the other hand, you have, and so often AI safety issues is when you're talking about the danger from the AI system. Whereas usually when people talk about AI security issues, they're talking about dangers to AI systems. So we're talking about, for example, the kinds of poisoning attacks that would compromise the integrity of the data that a machine learning system is using to learn, or more recently there's been a lot of research into these black box attacks that use adversarial images that fool. You talked earlier about TensorFlow's online, the APIs that are available, and there was a recent paper that showed that MetaMind's API could be fooled 96% of the time based on no prior knowledge of the image classification, just querying it and building a mock system to try to provide adversarial examples. So it seems to me, as a non-expert obviously, that these two conversations are happening in two totally different communities.
But why don't we talk about them separately first?
Okay.
Right, so let's talk about this question about, well, you pick which one.
Well, let's talk about AI safety first.
So AI safety is generally understood as the AI work is producing pretty much what we think it's going to do. And in recent conferences that I've been at, this is phrased at what point when the AI is intelligent enough to self-modify can we verify that the self-modification is correct? Right? Very reasonable intellectual question. Well worth a discussion. We are nowhere near any of these in real life. We're still in the baby stages of doing conceptual learning, trying to figure out what concepts are, basically deconstructing concepts and so forth. So in order to worry about that kind of question, you have to think 10 years, 20 years, 30 years, 40 years, which is a great ethics conversation. How do we make sure that the systems, when ultimately programmed, have the values that are human values, right? And I was joking about the Roomba decided to kill the dog. There are a gazillion examples which people worry about, where the AI system is programmed for one outcome. This is you're familiar with the Midas story, where he wants to double his gold everything on the chessboard. So if you don't specify the question correctly, you don't get the human values out of it. But to me, these are important philosophical issues, but not issues that we're facing right now. I think the other issues that you described, which I'm just going to call the accuracy question, for lack of a better term, is a much greater near-term concern. And it goes something like this. These systems depend on data, and they're trained against that data. So assuming a perfect algorithm, if the data has been fooled in some way, you could not get the outcome you expect. And so it's very important with these systems to understand that they are advisory, right? They help you understand something, but ultimately you want humans to be in charge of these things.
So, but then, I mean, one question it seems like, in terms of the relationship between these two concerns and these two communities, is that if you're worried about AI safety, you really want to be encouraging transparency so that everybody knows what else everyone is working on, so someone hasn't inadvertently come up with a proprietary, non-friendly AI system. But it seems like if you're working on security issues, you actually want to be a lot more careful about what you're saying in public, because it would allow for much easier generation of adversaries.
So I am, whenever you get into one of these questions where is it better to have your opponents know as much as possible or as little as possible?
Well, I guess it's slightly different because the opponents are different. In one case, the opponent...
But let me just put it as a game theory question. So the way it's classically expressed, and especially by the other side, is you never want to tell anyone anything, right? And because there's no benefit to you to giving that advantage up without a corresponding benefit. We've taken the opposite view, which is it is in our benefit to build a larger ecosystem which is completely transparent in these matters, including the bugs and the issues, because they'll get fixed faster. So there may be a few cases where this isn't true, but on balance, I would rather expose the shall we say, algorithmic weaknesses, using this mythical example of, say, bad data, because I know that there are thousands of you who will help us identify those, plug those deals, and so forth. And over again, there's greater safety, in my view, with more people looking at it. If you go back to the original rule about security, right, security is a series of layers of protection. It's not one incredibly strong firewall. That's what was broached a long time ago. And naive engineers constantly say, well, if we could just build a better firewall. It's not how it really works. Security is sort of a lifestyle. It's a way of thinking about things. It should be done at the data level, at the user level, at the application level, at the network level, and so forth and so on, in such a, again, the inverse of what we did in the 1970s, so that you can achieve this level of security. I'm quite convinced that if you build a system which is perfect and closed, you will find out that it's neither perfect nor closed. Right?
So, so moving on from that, let's go downstream to the device level. That we're living in this world where the predictions are that in 5 years we'll have 50 billion connected devices, and there's the concern that there's no market incentive for these devices to be secure, because they're built cheaply by third parties that don't necessarily have any brand recognition. Consumers buy them for price point and for features, and they upgrade every year, and that we're going to see increasing numbers of these Mirai botnet style attacks. So I wonder what given that it seems unlikely that there are market solutions to these particular externalities, I wonder how you see the role of somebody upstream like Google, especially as there's greater and greater demand for the data that these devices provide. What is the role for Google in dealing with that as a problem?
Let's distinguish between the end user device, the IoT device, and the network operators, of which Google would be one of many, many choices. I don't think I agree with what you said about market solutions and the IoT devices. It's a simple test, right? It's a straightforward advertising problem. If you buy this product, everything in your life will be ruined, you'll be spied on, and your entire bank account will be frozen. Buy this product for 1 cent more, and you'll be perfectly secure. Well, it strikes me there's a direct correlation between the economic self-interest of the vendor to have a secure solution, given that security is so cheap.
Well, but I mean, it seems like we're talking about a collective action problem, because we're not actually, the people whose baby monitors were used to attack Brian Krebs or whatever, like those people weren't actually seeing bad effects in their own homes.
You can be quite sure that if the competitor that makes the baby monitor that cannot be such attacked ran an ad that says that your baby is going to be spied on, pictures are going to be distributed everywhere, and your baby is at risk with our competitor's product, you can be sure that they can get a small amount of cents for the extra processor that's required to provide security on the baby monitor. I'm just not sure I agree with that. Okay. Maybe we just disagree. But to me, just to be blunt, fear works with respect to an advertising campaign about something which is really dangerous, right? Don't buy it because it will kill you. Strikes me as a reasonable advertising strategy from a security company, right? I mean, it has to be true, right? Right? I'm assuming it's true. I mean, don't lie about it. I think it probably works pretty well. On the network side, let's use a simple model. So we'll go back to, we have dumb IoT devices that are transmitting in the clear, right? So they're not encrypted, which I think is, in the Krebs attack, is the kind of thing you're talking about. And when you transmit in the clear, even if you don't transmit your password, you're transmitting enough information that interesting things can happen. I should add, by the way, that I'm very proud that Google, in our case, powers more than 2 billion devices using HTTPS, and that we have 100% of Gmail and so forth and so on. When HTTPS first came out, I thought, nobody's going to use this thing, it's used overhead. But the processors got faster, the algorithms got better, that for the last few years, your web use has been 100%, or in majority cases, majority protected. Your Gmail is 100%, and so forth. Use Gmail, by the way, for security, right? I always tell this to the government. They always love that. Use Gmail for your security and use two-factor for the same reason. And you do those two things, you'll be in pretty good shape. So let's think about business strategies on the network side. Well, you could imagine a number of companies that could interpose themselves in ways that would look at these data flows, do data analysis, and give alerts. And you could imagine a botnet alert network that said, hey, all of a sudden, the baby monitors have all woken up in synchrony. This has never happened in babydom, right? God decided that all the baby monitors should wake up and send pictures to one site. That's a highly detectable phenomena by a proper network analysis system. There are plenty of systems that provide proxy caches that could do that. There are plenty, Google would be just one of a company that might be able to do that, but there are plenty of people in the ecosystem that could provide these kinds of alerts, and would they be valuable? Yeah. I'm not trying to talk about baby monitors as a problem, I'm just using your example. But anytime you see a pattern, remember that AI is very good at looking for needle in the haystack problems and changes in patterns. So if that's not an AI-able, whatever the right word is, machine learnable phenomena, I don't know what one is. Say, every day, Monday and Friday, this is the pattern, and then on Thursday at 3, boom, right? Everything went trivially, to a UK server or a Lithuanian server or a Ukrainian server, and something's weird, take a look. And usually when you talk to the security people, they don't want you to solve the problem, although that'd be nice. What they want is they want the heads up. Hey, we noticed a change in pattern, check this out. And then they can use traditional investigative reports, tracking, traditional mechanisms, because it helps them focus their attention.
So to kind of zoom back out again on some of these bigger questions about AI, in the 6 months or so that I spent on and off with members of Google Brain, I noticed that not even one time did I hear anybody mention either the singularity on one hand, or on the other, this millenarianism, the apocalyptic scenario that we've seen other people describe. And it seemed to me that exactly as you said before, that people are having, and if you ask an engineer, he or she will say, well, it's hard enough to get this to work to do what I want. I can't even consider the fact that this is going to immediately become sentient and treat us all like lettuce. In fact, one engineer said to me that he thinks, in his view, that there's an inverse relationship between technical proficiency and willingness to speculate about these kinds of scenarios.
Plenty of smart people have made mistakes too, trust me.
But it does seem like the public non-technical discussion is so often dominated by, on the one hand, like the boosterish view of AI in the future, and on the other, the really pessimistic, like existential risk view. And it seems that there's this ever-growing gulf between the way that the engineers and the researchers are looking at it and the way that the public is consuming information about it. And I mean, especially given the wariness that so many of these companies have about journalists, for example, I wonder what you think can and should be done to close that perceptual gap.
Well, in our case, you studied what we were doing and wrote about it, and as far as I know, wrote without any restrictions. And your coverage was struck me as right on. Other people have done the same. So our approach is to try to do this in the open. We're trying to model this behavior. We're clearly one of the leaders in this space, and so if we can influence others, I think that's a better outcome. It's useful to know where we are, right? So I'll give you my favorite scenario of the future. What happens is, over time, general intelligence gets developed, the singularity occurs, the intelligence gets smarter than humans, the humans have a battle with the general intelligence, and the humans decide to turn off the computers. The intelligence is so smart, it hops from computer to computer, preventing the humans from turning off the computers, and eventually the intelligence wins and humanity is destroyed. That, by the way, is a movie, okay? That's a movie, right? It's not true, right? Can we start over? It's a movie. It has not occurred yet. We're still here. And more importantly, the scenario has an enormous number of assumptions. And in the 1970s, when we had analogous discussions, and if you go back, by the way, to the discovery of AI as a concept in the 60s, there were analogous writings of this at the time.
Oh, is the intelligence superintelligence explosion papers from like the 1963?
Think about 1963. There's a 1959 paper and so forth. It's all been well documented. So it's fine for us to worry about our future intelligence. One of my friends, Andy McAfee, says that the humans will revolt before the computers do, right? In other words, there's so much else going on. We should worry about ourselves, right? This is my personal view. So let's talk about where we really are. We have enormous strides in computer vision. And computer vision is now better in most scenarios than human vision. Huge impacts on transportation, self-driving cars, and the doctor. When you go to the doctor, what do they start doing? They look at your skin, they look at your tonsils, they look at your eyes and what have you. And we have result after result coming now that if you give the same picture to a computer, you get better diagnostic than a series of the best people if you show them enough pictures. By the way, it's not a fair comparison. The computer sees 1 million pictures and the human says 10,000 in their lifetime. It's just better training. The computers don't get bored. They can be trained 24 hours a day, that kind of stuff. So this vision result, which is I think the first of the results along with speech, which is similar to vision in the way it mathematically is done, means that systems will have human-like qualities with respect to vision and speech, which is not the same thing as AI. Right, but it means things that bedevil us, right? So traffic accidents, bad diagnoses in the medical system are going to get much better. These are clearly positive. And I will stake my reputation that that's going to be the real narrative over the next 5 years. It's hard to know what happens after that, but there are many startups here in the Bay Area and elsewhere in the United States that are busy essentially trying to take medical processes and transportation processes and essentially automate them in a relatively straightforward way, and the tools we provide allow that. So I would focus first on that. There are people who are working on more generalized intelligence, more powerful reinforcement learning and things like this. And those are at the research stage. As you know, last year we did a technology called AlphaGo, and we beat the human, who was a brilliant man, 4-1, right? And there's evidence that we've gotten significantly better in the last 12 months. So we're beginning, these algorithms are getting better, but again, they're all available to all of us to exploit.
All right. I think we're out of time, but
okay, thank you guys very much.
Thank you.
Okay, thank you.